Students, let's look at this question here, which is on the application of differentiation. And in this particular case is the connected rate of changes. This is a very particular question, very standard question where you have a ladder, PQ of length 5 meters. It's leaning against a vertical wall LM here. All right, and the base of the ladder Q is on the horizontal ground MN. Okay, so then at any instant, so basically this is a fixed length ladder, right? The assumption is that the length here is always being fixed. So imagine if this thing is falling off, then the ladder is always in constant contact here. It will also fall off here. Okay, so that's the idea. Now, at any instant, the distance P and PQ is represented by y meters, and for the horizontal distance here and 2x meters respectively, show that y is equal to square root 25 minus 4y squared. So essentially, this is just Pythagoras theorem. What you need to do just from Pythagoras theorem, we know that by Pythagoras theorem, we know that PQ square is equals to PM square plus MQ square. Okay, so this case will be 5 square equals to PM would just be PM square will just be y square. MQ will just be 2x square. So y square will just be this 25 equals to y square plus 4x square. So y is equals to 25 minus 4x square. So y, we take the positive one because y is positive. Okay. That's how you do this question here. I think this is pretty okay. Show that dy dx can be expressed as this form here, where k is a constant. I think it's pretty okay also. So now we could just differentiate this. So for part 2, when you do it, just put y, just bracket 25 minus 4x squared, then to the power of half. Then what you need to do is just multiply it down, and just differentiate by chain rule, right? So what I do here is that you get dy dx is outer layer, half, bring it down, will just be half. 25 minus 4x squared. Then half minus 1 will just make half. Then you move on to the inner layer here. Okay, so the outer layer would be this guy. Then you just go to it's just like an onion, just keep chain rule going in. So 25 will be 0, minus 4x squared will be 2 multiplied by negative 4 is minus 4, then x, right? So this is the case here. So when I simplify this will be, I could simplify this to 2, this is negative 4x, right? So negative 4x. This will just be 1 over square root 25 minus 4x squared. Or rather, this will just be 25 minus 4x squared half. So this case, what we get is k is negative 4. So hence, k is negative 4. Let's look at the last part. So for the base of a ladder Q, is sliding away from M. So basically, it's moving this direction. So imagine this is moving away at a constant rate of 0.125. So this is 0.125 meter per second, right? This is actually an increasing rate because x is increasing. So this actually just means as d. Oh, wow, this is a bit tricky. So this is actually mq is sliding over. So it's the d2x dt is equal to 0.25. So mq is actually increasing at this rate. Find the rate of change of y at the instant where x is 1.5. Okay, great. So this is part 3. This is slightly trickier. So what we need to understand is that d mq dt, mq, right, is mq, dmq dt is equals to 0.125 meter per second. So this is ddt, this is 2x, 0.125 meter per second. Meaning to say, if you differentiate this, this is this 2, we can bring it out. So dx dt is equal to 0.125 meter per second. Okay, so it's divided. So in other words, this guy dx dt will just be 0.125 over 2 meter per second. That's just an interesting question. So then what we want to find the rate of change of y at the instant. So rate of change of y is dy dt is equals to dy something something dt. So it's not an issue to know that this should be our dx and this is our dx. So dy dx is what we already found initially, which is actually -4. dy dx is this, right? This is dy dx. This is dy dx. -4x square root 25 minus 4x squared. Then the dxdt will just be 0.125 over 2. Okay, then we're just gonna, so when x equals to 1.5, dy dt here, when x equals to 1.5, we could actually just find out -4, 1.5, 25 minus 4, 1.5 square, 0.125 over 2. Okay, so this will give us, when keying calculator, -3 over 32 meters per second. Okay, so that's how you do this questionnaire proficiently. If you have any questions at all, please do let us know and I'll see you in the next question.